From whose point of view? And of what?
The speed of the particle from car's perspective in this case?
So the car's perspective, that's the prime frame. W is the speed of the particle from the car's frame. Car being S prime. This is the S prime and this is the S frame. So whose point of view is it?
The grounds.
Yeah. Or, the S frame right there, X over T. So this is just V minus U over 1 minus, well, I got it again, UV over C squared. Let's think about it from the point of view over here. Relating this to that, we have the speed of the ball with respect to the car would be the speed of, it'd be W. So this would be W. Speed of the car with respect to the ground, that's how fast the S prime frame is going with respect to S, that would be the U. And the speed of the ball with respect to the ground, that would be V. Galilean relativity, or the stuff that we've been dealing with, classical physics, we got BG, V equals BC, W plus U, or W equals V minus U. If special relativity were bunk, that would be the relationship between the speeds, or velocities. We have W equals V minus U. Lo and behold, we have W equals, well, that's my numerator right there. My denominator, those signs will always be the same. Those will be the two speeds we have right there, or velocities you have right there. And so I can then sort of extrapolate. I know that U equals V minus W. So in special relativity, that would be U is equal to V minus W over 1 minus VW over C squared. V equals W plus U. In special relativity, that would be V equals my numerator, same as it was before, and then 1 plus UW over C squared. So if I can just figure out what it would have been in everyday life, then I can just tack on the rest of it. So let's do the example. I got a rocket ship. And Earth back here. The rocket ship is going at 0.9 times the speed of light relative to Earth. So the velocity of the rocket with respect to Earth is 0.9 c. A ball is being thrown. The velocity of the ball with respect to the rocket is going at 0.5 times the speed of light. So the velocity of the ball with respect to Earth, Galilean relativity would be 1.9 times the speed, or sorry, 1.4 times the speed of light. But using this formula right here, I know that VVE equals VVR plus VRE. But since we're bringing in special relativity, 1 plus VVR, VRE over C squared. And now let's plug and chug. So that's 0.5 C plus 0.9 C over 1 plus 0.5 C, 0.9 C over C squared. The C's nicely cancel out. And I'm left with 1.4 C divided by 1.45. hopefully, you can see that that's gonna be less than the speed of light. .9 something. Well, it has to be bigger than .9, that's less than c, so. So when you get pulled over by the police for speeding, is that really the speed? Relative to what? Let's plug it into the formula. Let's see what my actual speed was. And then let me know how that goes. All right, I think it's time to revisit the problem, similar to the car garage. So it's this. All right. I've got a pole, a 16, let's be cool, do metric, 16 meter long pole. Traveling beta relative to the ground. Beta is 0.886. 886. One of them's going to give me a better answer than the other, so. Oh wait, number 6. You know what? We'll stick with this and see where it gets us. I have a 10 meter long barn. Now we're going to start the time in these two different frames. We have the pole that's traveling near the speed of light relative to the barn. From the pole's point of view, the barn's coming at it near the speed of light. But in this scenario right here, this is the prime frame. And this is the unprime frame. We have, basically I want to establish a position and time for 3 events. Left door closes. It's closes, not doses. Right door closes. And then pole hits the right door. This being the right door, this is the right side, and the left side for those who suddenly are getting it backwards. Now, the one thing that's going to happen that they will both agree upon is that when time is equal to 0, or they're going to start this, they're going to officially start time is equal to 0 as soon as the left end of this pole is inside the door. As soon as it's inside the door, the left door closes. So left door closes at, we'll call this position 0. Left door closes at 0 meters, 0 seconds. This is in the barn frame. And in the pole frame, it's measuring distance from the left end of the pole here, so this is x prime is equal to 0. So from the pole's point of view, it happens at 0 meters, 0 seconds. So this is x t, and this is x prime t prime. Now, from the bird's point of view, the pole's coming at it near the speed of light, so the pole shrinks. As soon as the left end of the pole is inside here, the right door closes. So this is going to happen at the position of 10 meters and 0 seconds. So from the barn's point of view, left and right door close at the exact same time. So let's figure out from the pole's point of view, what is its position and time that this happens? Well, I've got my Lorentz transformations right there. I know that x prime is equal to gamma x minus vt. And so first off, what's gamma? If that's beta right there, what is gamma? So be kind enough to calculate that. All right, so this is equal to 2.16 times x, which is 10, minus v, which is 0.886, times the speed of light, which is 3 times 10 to the 8, times time, which is 0. I'm going to change one thing here. I don't think we've gotten too far. Because this is 2.16, my memory was off. Let's go ahead and just make this 0.866. I think that's going to get me a more comfortable answer.
Now gamma is equal to.
Yeah, okay. So this would be 20 meters. So from the pole's point of view, the right door closes when it's 20 meters away from the left end of the pole. Make sure I said that right. The right door closes when it's 20 meters from the left end of the pole from the pole's point of view. Let's figure out what time it happens. T prime is equal to 2 times time, which is 0, minus x times the speed, which is 0.866 c over c squared, which ends up being 8.6, negative 8.66 divided by c, which is, that's 3 times 10 to the 8. And what do we get?
Negative 2.89 times 10 to the negative 8.
Or negative 228.9 nanoseconds. Negative 28.9 nanoseconds. So from the pole's point of view, the right door closes first and then the left door closes. From the Barnes point of view, they close, left and right door close at the same time. Let's figure out when the pole's going to hit it. So from the Barnes point of view, the pole is 8 meters long. That means it has to travel 2 more meters. This is, again, Barnes' point of view. It has to travel 2 more meters, and it's traveling at 0.866 times the speed of light. So this time that it's going to take the pole to hit the right door is going to be the distance divided by the, divided by the speed, which is 2 meters, divided by the speed of 0.866 times 3 times 10 to the 8. This would be meters per second. And the pole's going to hit the right door 10 meters, because that's where the, and the time is whatever's about to be told to me.
What is it the parentheses?
Sorry?
What is it, is it 3 times 10 to the 8 or?
Yes, 3 times 10 to the 8.
Eight times 10 to the negative 9.
So 8 nanoseconds. All right, so from Barnes' point of view, we have the complete picture. The pole is only 8 feet long because of length contraction. Pole's only 8 feet long. It's got 2 more meters to go. 8 nanoseconds after both doors close, the pole hits the right door. And so now let's figure out from the pole's point of view, at what time does that happen?
It was 7.7, sorry.
7.7?
Yeah.
And so now, from the pole's point of view, x prime is equal to gamma times x minus 10 times v, 0.866 times 3, that's a 6 there, 3 times 10 to the 8, divided by 3 times 10 to the 8 squared. Oh, no, that's a big mess. Let's get rid of that. I combine my 2 equations. X prime is equal to 2 times x minus 0.866c and a time of 7.7 times 10 to the negative 9th. And the c right here, that's 3 times 10 to the 8th. And the answer is
got negative 4.6 times 10 to the negative 3.
That's something's not right there.
What is that little squiggly line in front of the 10 represent?
This,
Yes,
that's an equal sign and then the number 2.
okay.
I got 18.
18? Anyone else get 18?
I got 15.9.
We need to go out another decimal place on the 7.7. Did anybody get either of those two values?
I got 15.9. I got, well, 16. I got 15.9.
Okay.
Yeah.
I missed a decimal place. I'm getting 18 now.
You're good. So we have 2 18s and 2 16s.
Is that 7.7 times 10 to the negative 9?
Yes. Is
Okay,
that what you did?
yes.
So we have 2 times 10 minus 0.866 times 3 times 10 to the 8th times 7.7 times 10 to the negative 9th.
I get 15.9. Same again.
So you're still getting 16
Yes.
and you're still getting 18? I think 16's right, so
Yeah, now getting 16.